So that's why I was thinking that.
Well, thank you, Nick.
Yeah, thank you.
And our final speaker of the session is going to be Hui Shao, who is approaching the podium now. And she'll introduce kind of the plans we have for the space weather assimilation with JEDI.
All right, good morning, everyone. I'm going to give a more introduction about JEDI. So some of them probably very basic because I would like to give you guys some idea about what JEDI looks like. So sometimes some slides already coming from a tutorial slide I did a few years ago, but I feel it would be good to bridge our knowledge with your expertise in space weather and to see how we can use JEDI for the purpose for this meeting. Well, Tom already have a very good introduction about our June Center's, the structure, etc. I just want to mention that because that confused some people already. We have our headquarters at UCAR, Boulder, but we do have a few outliers locating in other places, including myself. So we have offices at NOAA and NASA, our Maryland College Park Greenbelt areas. And my office actually is located at an NCWCP College Park, second floor, together with NSAP EMC. That facility, that connect us closer with the people we are working with. And that helps a lot, especially at the beginning when we build the unified forward operator. And, for neutral atmosphere right now, we're at a stage can transition everything go into operations. Communications are very important to help we move forward. So we started the JEDI project in 2017 and coding started around that time. And we are working with in-kinds closely. We have so many code sprints since then. And as we said that this is not a virtual collaboration. We are really working together. And sometimes we have drinking and working together. It works very well. We have virtual meetings since pandemic a lot. But we do feel this kind of working together mode help us to improve our code dramatically. And some of the pictures showing we have collaborators coming from European centers, from Met Office, sitting in the office together. And we talk about how we can merge our capabilities into JEDI. Now we have regular meetings with our in-kinds, weekly or bi-weekly, and we have different aspects to talk about. I feel personally, I really feel improved a lot of my own knowledge about how other centers doing their data simulation. And I feel this would be a great example for us to proceed with space weather. That's why we are here today. So very basic introduction you have known already. We have observations, we have background, and we want to generate analysis. And using forecast model, we proceed to the next time. And that forecast can come back as a background. So really, if we simply think we are trying to find a weighting matrix, which is gain matrix that to define the weighting we can gain from observations and optimize between the background and observation information. So this has been shown up a couple of times already. I want to use the terms coming from this cost function being used by variational data simulation system. But for ensemble, we have a different formula, but using similar terms because if the distribution are all function, a Gaussian distribution and the forward operator is linear, the ensemble-based data simulation methodology is equivalent to variational methodology. Of course, in reality, they are not. But anyway, we are using similar terms. We have analysis, we have background, And we have background errors, which is describe the uncertainties for the forecast model. We have observation forward operator all here. And we have observation error covariance. I want to mention that for observation error covariance in our data simulation system, it's not only talking about the measurement errors, it's in combined the forward operator errors and also observation side. So that's one thing we need to remember when we define this. So anyway, Francois yesterday already mentioned we have abstract layer to define classes and methods, and then we have a generic layer to be the interface between the abstract layer and the specific implementation. So for me, today's emphasis is on the forward operator part. So I just talk a little bit about here is, for example, we have specific readings data, for example, you could using CRTM or RGTOF, a different radiative transfer model. And we are using similar interface to talk with the abstract layer. So you can see any model, when they transfer their state variables to the abstract layer, we don't really directly talk to each model. We just get information from this layer. So what that means, so really for forward operators, we are communicating with state variables that, that interface, model interface. And we grab the field values at the locations, which we call the dual vowels. So we don't really know where the state variables come from. So if we can make sure we are keeping the generic interface working, and for each specific operators, it can be adapted to other models over this side. So that's a major effort. But on the other hand, that means if we have a forward operator implanted, for example, coming from Med Office, as long as we can make sure it's genetically enough, the GFS, FB3 model can use that as well. Of course, there's more testing to be done for that kind of, plug-in type of operators. But on the other hand, this kind of generic setup make that possible. Minimize the efforts compared with existing model or data simulation system. And I also want to mention this one is what HFX or what components we are included in the unified forward operator UFO in JEDI. So yesterday, Francois mentioned that there's interpolation coming from the model side, from a model interface. So you can think about the H, the forward operator is decomposed into a few components. The first component is being done over the model side, which is the horizontal interpolation. And of course, the forecast model propagated from the different time steps, that's also being done over the model side. So traditionally, that's part of H, but now we put them into model interface part. And for the UFO side, we have the transition, the leftover part, transition the state variables to observational space. So sometimes it's including vertical interpolation or, more complicated transform, like a radiance transform or gene SSRO bending angle computation. So that's why it involves, if you have different grids coordinates, the first step need happen over the model side, and that's what's been discussed yesterday. And for the UFO, we will take care of the other part. And here, this is a very simplified figure to show what UFO received at this point. We received the vertical profiles for each single point, or sometimes multiple profiles if we need. And for the UFO, we take care of the other side, the leftover side for the UFO transform. All right, so let's take a quick look what the JEDI looks like when you use JEDI system. It includes forward operators, nonlinear and tangent linear, the code for the UFO, of course, and you have different operators. Now we covers most of the observations used for neutral atmosphere, conventional satellite retrievals. We also interfaced with external packages. If you have heard about the CRTM, RT12, ROPP, we have bias correction. We also have filters and ops functions. They are being used for quantity control, thinning, actions like you assign values to certain variables you would like to have, and also variable transforms. So they are all YAML controlled. So you just have, in this figure, you can see we have ops operator defined as CRTM, and there's a particularly key item you need to use with CRTM. And you also have bias correction. We need to define different predictors, and you can have the bias correction for your observation type. And then you use the filters. You either can use to look like cloud for this situation, different type, different parameters. So this is just the YAML controlled configurations you use for one type of observations. And you can combine all of them and you will have control files for your system. So currently we have a more generic QC implemented or specific ones. For example, we mentioned that 3 sigmas you can use for observation and background QC, and that's generic in our JEDI system already. We have bound check, domain check, background check, which is O-B, rejection, accept. You can also perform a certain action, create diagnostic flags. But of course, if you want more specific ones, we also have some already, but we can also create specific ones for the system you particularly developed for your system. And the right-hand side, again, showing example that we would like to have some flags to indicate which QC has been used. And then we define the filter settings in the second part of the YAML files. And we also, so with all this setup, we can either use that for HVACs or for a data simulation. We can also use this kind of information to monitor the performance of different models or different observation types, different missions. This is one example. I just have the snapshot from our web page to look at observational-based verification. And once you have operator implemented, we have the choice to select the different observation times from this website demonstrator. And we can look at the O-B, O-A information. And for example, if we will have different configuration of models, when we have this, we can look at their fit to different observation types to look at the performance of that kind of configuration. There's still a lot going on to make this kind of tools more adapt to our needs. But on the other hand, personally, I really feel this helped us to evaluate new missions and the new configurations in our current test. Okay, so related to the separation concern with the structure, we have JEDI system. We also decompose our task into different components. And for Space Spider, we have data ingest, which we also mentioned yesterday, that we convert all the different types of observations into a unified format we call the UDA format. And we create UDA converters. So, our customers doesn't need to take care of that part. Of course, we're working with our expertise on the data side. And then once we build that database using this data converters, we will have a unified data format that we can ingest into our JEDI system. What we need to do is we need to define naming conventions. We still don't have that for Space Spider community. And we also need to understand what kind of metadata should be included in our UDA converters. So that's something I would like to discuss later. Forward operators already mentioned, and we need to bridge our knowledge from neutral atmosphere to space weather. I have some analogy to show what I think we can already take advantage of what we have had already. Data simulation solver right now, based on what we understand from NRL, we are going to try with ETKF and LETKF we already have in JEDI. And the forecast design plans are very important, and Francois is in charge of that. And naming convention for the state and GeoWalls are also important. That's separated from observation, but we also need to map the two components together. So that's some work to be done. And also the interface part is, the real work is very complicated from yesterday. We need to proceed with that at some point, but right now we are using PyRI as a proxy of SEMI3. This is more because, we are working with our stakeholders at this point, but we are hoping development will be generic enough to extend that to other models in the future. Okay, yeah. So now we already have PyRI JEDI repository inside Student Center internal. And also just last week, now it's part of JEDI bundle. And JEDI bundle, including all the model we have implemented and also the UDA, UFO, all the components together. So really appreciate the work from NRL, in-kinds, and also our Student Center core people. So you can see in this figure showing that it's easy to add a component, of course, just to look at this CMake file. But on the other hand, there's more related to that. We would like to have automatic CI test so that whenever all the pieces is evolving every day, we want to make sure our model, particularly for this PyRI, work is moving forward with all the other components. So this is active maintenance we need. And we will share, and we are sharing this with our in-kinds at the same time. So converters, we already have anasound and also the RO total electron density conversion. You can see the UDA converters works okay, looks reasonable after conversion. We have 2 PR already merged into our develop. And there's still refinement to be done, but at least the first versions looks reasonable at this point. All right, so just a example how we are going to use our neutral atmosphere operators for space weather. So if you just look at the RO as example for refractivity, this equation coming from a paper many years ago. So you can see that refractivity is a function of neutral atmosphere part is the PTQ, and for ionosphere is the electron density, and there's other cloud effects, etc. So if we separate them, neutral atmosphere, you ignore the ionosphere part, and that's what we implemented in current JEDI. And for ionosphere, we need to remove the neutral atmosphere and only using one term. Hold on a second. Okay. So if you look at neutral atmosphere, we follow the retrieval and reverse that, right? That's how you build your forward operator all the time. So we start with the model PTQ and we calculate refractivity N. And then what we are doing right now, following most operation centers is we are using bending angle as the control variable we assimilate. So we have refractivity operator, we have retracing or about transform operators right now for neutral atmosphere. So for TEC, I read paper back to 1999 from Schreiner, and I'm pretty sure there's newer papers about that. But I just want to draw a simple chart. If you look at that, the retrieval process is very similar to what we already have for neutral atmosphere, just replacing the bending angle with TEC. And then from there, there's electron density. And please forgive me if my understanding is limited. It's a quick review. But anyway, if you look at the forward operator, electron density assimilation, we can use vertical interpolation we already have from the radio sound. And if we want to assimilate TEC, we can use either retracing we have already, or you just use straight line assumption, or we can use about transform we already have as well. So my understanding is we probably will proceed with retracing. So that's, I feel when I look at this, I feel, oh, good. At least I know something already, even though I don't know that much about physics part. So last week I tried just convert radio sound YAML to electron density, and there's not much to really change from the YAML files. Of course, behind the scene, we have to do some name mapping, do some variable, making sure they're working with the new variables coming from the electron density part. And also the data have to be converted correctly. And that's the part that I'm working on right now. But if you look at the YAML files, we can just basically follow what we have done for the radio sound. And, there's something I would like to have to making sure the naming convention is correct and the time, etc., coming into right. But this is how we are doing. The adaptation, at least for the electron density part, is relatively straightforward. All right, so I don't have a lot of results to show today, but I just want to say we are moving forward to that and trying to use our knowledge base for space weather, and there's a lot more to learn for myself. And we are having first version work converters already, and the actions is we need to have a working group for naming convention and metadata. We are trying the simplest way at this point. For example, we are using process data like electron density, but future direction is we would like to move forward, if possible, go to raw data that will reduce the errors introduced from the retrieval process and probably giving us more, the information from the observables. But again, there's different selections which we need to discuss. Solar part we haven't touched yet, but I have heard a lot about how to do the localization, or maybe no localization, correlation, covariance, that kind of stuff we need to discuss. And also, eventually, we hope to set up the system we can run more or less in the cycling mode. And with the model part Francois already mentioned, I don't think I need to repeat, but the most important, it seems, we need to discuss how to add a geomagnetic graded model into the coordinated into JEDI. I think that's it. Okay, so prepare for the futures. That's what we are working for this week. But I hope this is not at the end. This is a start. We are working together, and we need to look further, because my work right now is focusing on what has been done, but it should be focused on that. We should look forward to see what has to be done and in the future, so we can start from now. And that's it from me. Thank you.
All right, so we're a little bit behind on time. I suggest if there's no urgent questions, we go straight to the break and convene at the top of the hour. That'll give us 10 minutes and change for a break. All right, well, thank you, everybody. And again, for those online, we'll reconvene at the top of the hour with the discussion.
I would say diagonal covariance problem for terrestrial studies. Yeah. Yeah, it's honest work. It's lots of money to do.